Hello, my name is Dylan Hacker, and today I will be showing you how to find the density of a log floating in water, assuming that there is zero acceleration, and assuming that the log is a perfect cylinder. So starting off, I would like to draw the log for you. So assume that is a perfect circle. Not the best at drawing. Alright, so this perfect circle, this perfect cylinder right here is going to have a radius of little r, a length of big L, and it is floating in water, so I'll draw the water level like that, and from the top of the log to the top of the water right here is going to be known as little h. So since the log is at zero acceleration, we know that the buoyant force, what's keeping it up and floating, is going to be equal to the weight of the log. So we know the weight of the log is equal to the mass of the log times g, which is the acceleration due to gravity. And we know that the buoyant force is equal to the weight of the fluid displaced. So this means the mass of the water times the acceleration due to gravity. So these two g's can go ahead and cancel out. And we know that the mass of the water is also known as the density, rho, of the water times the air times the volume of the shape of the object we're talking about. So the volume of the object we're talking about has a weird little majority of a circle, right? And then it's cut off right there. So we can draw that shape right there. Basically the circle without the top portion where the water isn't on. That area times the length of the log is going to be equal to the density of the log times the volume of the log, which is pi r squared times the length. So we can go ahead and cancel out those lengths right there. We get the density of the water times the surface area of the water that is not being, or that of the water that is surrounding the log, is equal to the density of the log times pi r squared. So now we know everything besides this, which is what we're trying to find an equation for, and this weird shape right there. So we got to find out what that weird shape is equal to. So basically we know that it is going to be equal to this minus the top portion, which is drawn like this. I'll move this down a little bit, make it a little bit easier. Alright, we know that the big circle is pi r squared minus this weird little shape right there. So in order to find this, this is a straight line. In order to find this, we have to think of another way to find it, and this right here, this weird shape, is going to be equal to this area of the circle minus this triangle that is inside the circle. So in order to find this right here, we have to draw the circle. That was really bad. We know this to be h. So the middle is right there. This is r and little r. And that's r right there. And this right here, r minus h. So in order to find this area right there, we're going to need to know the angle that it is at. So we'll call this theta, call this theta. So we know that 2 theta divided by, we have to put it into radians. And in order to do that, we have to divide by 2 pi, which is the circle, 2 pi. And to get it of this specific circle, we have to multiply it by 2 pi r squared. Alrighty, and once we do that, we get these two cross out. Alright, it's pi r squared, I apologize. Pi r squared, which is the area of the circle. Yes. So once we get that, we know that pi's cancel out. We get theta r squared is equal to that area right there. My squared went away. So once we get that, we have to figure out what theta is in terms of r and h. So we get theta equals the cosine and it's SOHCAHTOA, so it's adjacent over the hypotenuse. Adjacent in this case is going to be r minus h over r. So we get this to equal cosine -1 of r minus h over r times r squared. Once we get that right there, we know that that is the area of this whole shape. That whole area right there. Now we just have to find the area of the triangle, so we have to subtract this by the area of the triangle right there. And in order to do this, we have to use the Pythagorean theorem to find out this angle x. We're going to call that x right there. We need the whole thing. And we know that the area of the base, the area of the triangle is going to be 1/2 base, which in this case is going to be 2x times height, which is r minus h. Those two cancel out, so you get x times r minus h is going to be the area of the triangle. And now in order to find x, we have to use the Pythagorean theorem. So to do that, we need the hypotenuse. We'll do this under here. Hypotenuse squared is going to be equal to the 2 side lengths added up when they're squared. Alright, now we have to simplify for x. We can factor out that r minus h squared and get x, move this down a little bit, x is equal to the square root of 2rh, 2 times the radius times that height portion up at the top, minus h squared. So once we get that, we can go ahead and plug that back into our equation right up here. So we get the full area of that small little sliver at the top. Just this portion right here is going to be equal to cosine -1 of r minus h over the radius times r squared minus that area of the triangle, which we found out to be r minus h times the square root of 2HR minus h squared. So now that we have that, we are almost done. We have to put that back into right there, subtract it from pi r squared. That is the area of the small little sliver, or that's the area of the portion with the small little sliver cut out, that right there. We have to multiply it by the density of water, which is 1,000 kilograms per meter squared. And then divide it by the area of the log, which is pi r squared. And that right there is the formula, the equation for finding the density of the log. Thank you guys so much for watching. I hope you guys have a great rest of your day.